Okay, hello. I think this is my third time trying to record this. I'm going to be going through the geometry study guide and the problems and how to solve them in a video tutorial. I hope this helps you prepare for your test that's on Thursday or Friday, and we'll just go ahead and get started. I'm going to turn my camera off, but I will be going along with you all. So let's go. Here we are, the Trig test study guide. So for this, let's start with topic 1, identifying right triangle sides and using SOH CAH TOA. So here's the standard right triangle. We know it's a right triangle because right there we see the little square to tell us it's the right triangle. Whenever we're talking about a side being adjacent, a side being opposite, or a side being the hypotenuse, we're always talking about it with respect to an angle. So right now, in number 1, in this problem here, our angle is the angle X. So when we're standing at this angle over here, how do we find the side opposite? Well, the side opposite would be, here I am at my angle, and if I were to draw a line through the triangle to the opposite side of the triangle, that's how I find opposite. So there's my opposite side with respect to angle X. So that's our opposite side. To find our adjacent, well, before we go to adjacent, let's talk about what the hypotenuse is. So the hypotenuse is the side that's opposite the right triangle. The hypotenuse is also the longest side length of the triangle. So here's my right triangle, my right angle, go opposite of the right angle, and that's how I find my hypotenuse. The last one would be the side adjacent. The side adjacent to our angle X, well, it can't be the opposite side. It can't be the hypotenuse side. Adjacent means to be next to. And when we look at our angle X, well, there are two sides that are next to our angle X. There's this side and there's this side. But we already labeled this side as the hypotenuse, so it can't be that side. This side is our adjacent side with respect to our angle X, okay? So if we were talking about the other angle over here, this side is opposite and this side is adjacent, and the hypotenuse is still the same. So you can see how the adjacent side and the opposite side flip depending on which angle we're standing from. So that's how we identify adjacent, opposite, and hypotenuse. We need to know what sides we're dealing with to decide which trig ratio, sine, cosine, or tangent we will use. So we've already done the sides opposite, adjacent, and hypotenuse to our angle X. Now let's talk about what SOH CAH TOA is and what these trig functions are. So SOH CAH TOA, I'm going to write that here. We have so as here, this is sine with opposite. This might not be the best way to write it. Let's do it like this. We have so, where we have sine is opposite over the hypotenuse. We also have CAH. Oh, I meant to do it this way. We have CAH, and that's cosine, which is the adjacent side over the hypotenuse. And the last one is tangent. And tangent is TOA, TOA. Tangent is opposite over adjacent. Oh, that did not type. Adjacent. Okay, so it's really important the order of the letters in SOH. It tells us exactly what the ratio is going to be. As in for sine, we're talking about the opposite side length value over the hypotenuse side length value. And for cosine, we're concerning ourselves with the adjacent side over the hypotenuse side. And tangent is the opposite side over the adjacent side. So when we have a triangle and we need to decide if we're going to use sine, cosine, or tangent, we're going to ask ourselves, well, what information do we know and what are we trying to solve for? So if we're missing the hypotenuse and we know the value of the opposite side of our angle, and we know the value of that angle, then we're going to use sine. But we'll practice this on the following problems and actually writing out our trig ratios, as now we know what sine, cosine, and tangent stand for. SOH TOA. So let's move on to topic 2, using the Pythagorean theorem to find missing sides, or to find a missing side, and writing trig ratios. So the Pythagorean theorem, I'll write this here. We have the Pythagorean theorem. And that says a squared plus b squared equals c squared, where a and b are legs and c is the hypotenuse. Okay, so in our triangle PQR, I see we have a right triangle. There's my right triangle. There's the right angle. And we don't know what this side length over here is. They didn't tell us that, and we have to use the Pythagorean theorem to decide, not decide, but to compute what that value is, what that PQ side length is. When we label sides, we label them the letter opposite of the angle. So remember how we were finding angles and finding which side is opposite? Well, this angle R, if I were to draw through the triangle to the opposite side, that's this side length. So we're going to label this as R. You could label it as X or Y or A or 2, not 2, sorry. But like you could label it as whatever, but I'm going to label it as R because that's what we typically do. So to find R, I know that this side and this side are the legs. How do I know that they're the legs? Well, the two sides that make the right angle, the two sides that make the right angle are the legs. And the other side over here is the hypotenuse. The hypotenuse makes the two acute angles. So here we have our hypotenuse, and here's a leg over here, and here's a leg over here. So what I'm going to write now is I'm going to write 14 squared plus r squared, we don't know what r is yet, that's what we're solving for, is equal to 50 squared, because c is the hypotenuse, and the value of our hypotenuse is 50. I'm going to give a little more room here. And what I'm going to do now is I'm going to just compute these. There's a couple ways I could go about this, but I'm going to go for, I'm pulling out my calculator. I'm going to find out the value of 14 squared. 14 squared is, 14 squared is 196. So that's the value of 14 squared plus r squared, we don't know what that is yet, is equal to, and 50 squared is 2,500. The next bit is to move, let's see, I'm going to use a darker color, move this 196 to the other side because we're trying to isolate our variable r. We're trying to get r by itself on one side of the equal sign. To remove the addition that's happening here between positive 196 and r squared, I'm going to subtract 196 from both sides. That will cancel out the positive 196 and that subtracting of 196. So that is gone now. And on the left side, we have r squared is equal to 2,500 subtract 196 is 2,304. The last bit is we need the value of just r, regular r. Right now we have r squared. The way to undo anything to the second power, anything squared, the way to undo that is to use the square root function. And the square root, if you remember, it looks like something like this. So using the square root function undoes the exponent to the power of 2. So what happens is the square root function cancels out the power of 2, so we just get regular r is equal to, and the square root of 2,304 is equal to 48. Quick note, whenever we take the square root of something, it's either positive, plus or minus, positive 48 or negative 48. But because we're talking about the length of a triangle side, we know it's not going to be negative 48. It has to be positive because we're talking about length. So I know r is to be 48. And I'll go ahead and write that up here. 48. Okay. That's a weird 4. I don't like it. 40. Nope. 48. Okay. So now that we know the three values of our sides of our triangle, we can now use our trig ratios to fill in the last little bit. I'm going to do that. And remember, up here we have SOH CAH TOA to help us write our trig ratios in the correct orientation. We're going to start with the angle Q. So if we're at this angle Q over here, and I'm looking from this angle, and I'm asked to find the sine of angle Q, well, I need to know what is the opposite side of angle Q and what is the hypotenuse of our triangle. So here I am at my angle Q. I'm going to go through the triangle to the other side of the opposite side of my triangle, and I see that from angle Q, this leg over here, PR, with the value of 14, is the side opposite of my angle Q. And since sine is opposite over hypotenuse, I'm going to write 14 in the numerator over the value of my hypotenuse. And my hypotenuse, which I already wrote here, is 50. So here I'm going to write 50. 14 over 50 is sine of Q. It also asks us to write this in simplest form. And I know that 14 and 50 can be reduced by 2 because they're both even numbers. So I'm going to factor out 2, or I'm going to divide both my numerator and denominator by 2. 2 over 2. And that'll be equal, well, 14 divided by 2 is 7. 50 divided by 2 is 25. So that's the value of sine of Q. All right. Now, if we're asked to find the cosine of Q, well, cosine is adjacent over the hypotenuse. So from my angle Q, the side that is adjacent to angle Q is this side over here. This is my adjacent side. This side is adjacent because it's the one next to my angle Q and it's not the hypotenuse. So here I'm going to write 48 in the numerator because for cosine, the ratio of cosine is the adjacent side over the hypotenuse side. The hypotenuse of the triangle never changes. Doesn't matter which angle we're asking about. The hypotenuse of the triangle is always the same. In this case, the hypotenuse is 50, so it's 48 over 50. Again, we need to reduce our fraction in simplest form, and I know that this can be reduced at least by 2 because they're even numbers. So 48 divided by 2, that's 24. So I'm going to write 24 up here. And 50 divided by 2 is 25. And that's its simplest terms. The last trig ratio for our angle Q is tangent of Q. So TOA. Tangent is the opposite side over the adjacent side. And for our angle Q, well, opposite is 14. We already found that out when we did sine. And the adjacent side is the 48. So we have 14 over 48 is the tangent of our angle Q. And let's reduce that fraction, divide by 2, or factor out 2 from the numerator and the denominator. And we get 7 over 24. So we figured out angle Q, the sine, cosine, and tangent of angle Q. Let's move on to angle R. Here's angle R. And now the ratios are still the same, as in sine is still opposite over hypotenuse, cosine is still adjacent over hypotenuse, but now we're talking about it from angle R. And from angle R, the side opposite of angle R is now 48. It's this one up here. It's not drawing. Hello. It's so weird. There. Okay, that's the side opposite, because now we're at angle R, and we still have to draw through the triangle to get to the other side, and that's 48. So the opposite side for angle R is 48, and the hypotenuse doesn't change. It's still 50. So there's 50. Again, I'm going to reduce by dividing by 2. And I'm going to get 24 over 25. Quick thing to note right now is I see that the sine of angle R is the same ratio as the cosine of angle Q. This isn't coincidental. This is because the opposite side and the adjacent side flip when we are talking about the two acute angles. So spoiler, the cosine of angle R is going to be the same as the sine of angle Q. And let's just check it out. So for the sine of angle Q, for the cosine of angle R, which is what we're trying to find out, is cosine's adjacent. And from angle R, the adjacent side is right here. This side is the adjacent side, the 14. And the hypotenuse is still 50. So 14 over 50. And again, we're going to reduce our term, divide by 2. And that's going to be equal to 7 over 25. And it checked out. This ratio, 7 over 25 for the cosine of angle R, is the same ratio as the sine of angle Q. Last bit is the tangent of Q. Tangent is opposite side over the over the adjacent side. Tangent is opposite over adjacent, TOA. So the side opposite of angle R was the 48, right? So I'm going to write 48 on the numerator, and then the side adjacent to angle R was 14. I'm going to divide by 2. And that's going to give us the ratio 24 over 7. Awesome job. 1 second in the video. Bye, everyone. Have a great day. See you in the afternoon. We'll be doing a study review session in asynchronous. So if you want to review for your test, come on by to async. Have a great day. Bye, Mr. Thursday. All right, bye, everyone. Okay, so I'm back. All right, so and the thing to note about this is the tangent of one of our acute angles is the reciprocal of the tangent of the other acute angle. Reciprocal means that this 7/24 is flipped. What was in the numerator before is now in the denominator, and what's in the denominator before is now in the numerator. All right, so we're done with topic 2. Oh, sorry. Why isn't that erasing? Okay, done with topic 2, let's move on. Topic 3, using trig ratios to find missing sides. So we need to solve for the x side, whatever was labeled x. In this case, we have for number 8, let's check it out. We have this side that we don't know. We don't know the value of this side, but we're going to use our trig ratio to figure that out. So to find out what trig ratio we have, well, let's identify what information we have. We have this angle, 37 degrees. From this angle, 37 degrees, what is this side over here? And what is this side over here? What information about sides do we have, or are we trying to solve for? Well, this side, x, where x is over here, that is our hypotenuse. Why is it the hypotenuse? Because it's the side opposite of our right angle. There's my right angle. Opposite of the right angle is the hypotenuse. So x is the hypotenuse. That means that this side, the 48, must be our adjacent side. It's adjacent because it's right next to our angle, and it's not the hypotenuse side. So we have hypotenuse and adjacent. To decide which trig ratio to use, sine, cosine, or tangent, well, let's go back up to SOH. Where do we see, and this is H for hypotenuse and A for adjacent. Where do we see A and H in our SOH? That would be cosine, right? Right here, I see an A and an H. So cosine is the trig ratio that I'll use to solve for x. That means I'm going to take the cosine of my angle. We always take a sine, a cosine, a tangent of an angle. So I'm going to write cosine of my angle, 37 degrees, is equal, and remember cosine is CA, so that's adjacent over hypotenuse. A comes before H in the CA, so it's adjacent first. So I'm going to write 48 first in my numerator over my hypotenuse, which is x. So the trick to solve for x here, the shorthand trick, is to flip these two. As in, we're going to have x is equal to 48 divided by cosine 37 degrees. That's the shorthand. I'm going to show us why we have it that way. Why is it 48 over cosine 37? And here's why. To get x out of the denominator right now, we have 48 divided by x. We want to isolate x, right? We want x alone on one side of our equal sign. To get that, we need to undo the division that's happening between 48 and x. To undo division, we use multiplication. So we're going to multiply both sides by x, which is what's in the denominator. That will be x times cosine 37 degrees is equal to 48x over x. 48x over x, well, those x's will cancel out. So now we have x times cosine 37 degrees is equal to 48. But now we have another problem over here. X is being multiplied to cosine 37. But like I said before, we want x alone. to undo the multiplication that's happening between x and cosine 37, and cosine 37 is its own value. You can plug in your calculator cosine 37. You could use the trig table to find out what cosine 37 is. But before we even do that, let's just get rid of the cosine 37 that's being multiplied to our x by using division, because division undoes multiplication. Cosine 37, I'm going to divide by both sides as the rules of algebra say. And what happens here is this cosine 37 over this cosine 37 cancel out. So what we get left is just x is equal to 48 divided by cosine 37. And I'll rewrite that like this. X is equal to 48 divided by cosine 37 degrees. I will show you one way to use the trig table to solve this, if you want to use the trig table. Well, we have to find out what the value of cosine 37 is. I'm going to go to the trig table. It's in week 7. I'm going to go to the trig table. The trig table is the column A, as in this column here and this column here. Those stand for angle values. So I'm going to find where A is 37. Here's A being 37. And we're taking the cosine. So this is sine, the middle one is cosine, and I'm taking cosine, so I'm going to go to the middle one right here. 0.7986 is the approximate value of cosine 37. So what I'm going to do here is I'm going to say, is equal to 48 divided by, what did I say? Cosine is about 0.7986. And I'm going to plug in my calculator, 48 divided by 0.7986. And that is approximately, if I'm rounding to the nearest tenth, that's approximately 60.1. So that's my approximate answer right there, is the value of x. The other way we could have solved this one is using a calculator. You can plug into your calculator 48 divided by the value, 48 divided by cosine 37, and you would have gotten approximately that same thing. One thing I'm going to show you right now, though, is how to just use like Google or Bing or whatever to find that. So what we had to do, remember, is 48 divided by cosine 37 degrees. I'm going to write that right here. 48 divided by cosine 37, and I'm going to write the word degrees because there are multiple ways to measure angles, and we are caring about degrees. So I am writing degrees, and I am telling you to write degrees when you do this in your calculator online. And there you go, 60.1 degrees. Cool. So that's how we do number 8. I'm going to skip showing you how to do number 9 because it is essentially the same. Well, no, I'll go ahead and do number 9 with you. So for number 9, what we'll do is we'll have to ask ourselves, what trig ratio will we use to solve for this one here? Here's my angle, 24 degrees, and I have this side and I have this side. So I have to decide which trig ratio to use. Well, from 24-degree angle to get to this side x, that's my opposite side. This side is opposite because I have to go through the triangle and hit the other side, and I got my opposite side there. This 9 is the hypotenuse. Why is it the hypotenuse? Well, because it's opposite of my right angle. So I have to go look at SOH CAH TOA and see, where do I see an H and an O? Where do I see an H and an O in my SOH CAH TOA? And I see it in sine, right here. Sine is opposite over hypotenuse. So I know I'm going to take the sine. I'm going to take the sine of my angle, 24 degrees, and I'm going to set that equal to the opposite side length. In this case, that's x, over the hypotenuse side length, which is 9. To find the value of x, we're going to multiply both sides by 9 to get rid of the 9 that's being divided by x. So then we have 9 times sine of 24 degrees is equal to 9x over 9. Well, those two 9s will cancel out. So now all we have is x is equal to whatever 9 times sine of 24 degrees is. Super, super. All right. So I've showed you how to use the trig table. I've showed you how to use the online calculator. What I'm going to show you now is how to use a phone calculator. If you're someone that has an iPhone and you want to use your iPhone or like any other kind of phone calculator, you need to unlock your phone so you can rotate it and go to the, okay? And now I can rotate it and you can see how there's a bunch of more functions over here. Before it's just the standard situation. Now we have all these other functions. What you have to do, and we're taking 9 times sine of 24. Well, to find the sine of 24, I have to put in 24 first, and then I can press the sine button. That is the value of the sine of 24. You have to press the number first and then press the function. If I were to do the other way around and press just sine first, they're thinking I'm taking the sine of 0. So I need to put in the value that I want to take the sine of first, and then I'm going to multiply that by 9, and I'm going to get, wait a minute, is that right? I think that's right, and we can check. Let's check it on here. So 9 times sine of 24 degrees. Cool, that's what I got on my calculator as well. So to round this number to the nearest tenth, that means that we need to round this number, the first decimal. This number is either going to round to a 6 or to a 7. To decide if this rounds to a 6 or a 7, we look at the next number to the right. If the next number to the right is 5 or above, we round up. So we're going to round this to 3.7. We're going to have x is about, and this little squiggly sign is about, so x is about 3.7. And there's our answer. Done. All right, let's move on. We only have a couple more problems. Using inverse trig ratios to find missing angles. So inverse trig ratios. Sounds scary, it's not scary. So if back here we were finding missing sides and we were using the angles to help us find missing sides, now we have the value of 2 sides, but we have a missing angle. So let's figure out how to find this missing angle. For number 1, here's my angle x. We still use the same process of deciding sine, cosine, or tangent ratios, even if we're having a missing angle. We still care about what angle we're standing from, where we're positioned, and we're at angle x. So we have to decide if this side and this side, what sides are there? Are they the adjacent, the hypotenuse, the opposite? So from angle x, I draw my line through the triangle to the opposite side, and I hit the 15. So the 15 side length is opposite. Here I am at my right angle. The opposite side of my right angle is the hypotenuse. So I have the hypotenuse side and the opposite side of my angle x. When I look at SOH CAH TOA, where do I see O and H? Well, we talked about this before. O and H show up in the trig ratio of sine, because the trig ratio for sine is opposite over hypotenuse. So I'm going to go back here, and I know I'm going to take the sine of my angle x. I'm going to take sine of my angle x in degrees. And remember, sine is opposite first. So 15 over my hypotenuse, 24. Okay, multiple ways to solve this. I'll first go through how we can use the trig table. If you want to use the trig table, it's going to be an approximation. And what we do is we're going to ask ourselves, what is the decimal value of 15 divided by 24? The decimal value of that is equal to 0.6. So wait, actually, sorry. I'm going to write this like, this could be, that's not very clear. It'll be sine of x is equal to 0.625. So what I do is I go to my trig table, that's in week 7. I go and look at the sine column, because we're taking the sine of an angle, and that sine of whatever angle value it is equal to 0.625. I go to my trig table and I look at the sine column, which is like the second column in, and I find approximately where 0.625 is. So here's 0.6293, here's 0.6157. So I know that the angle is going to be between 38 and 39 degrees. That's the trig table method. So I'm going to go back here and say that my angle x is either, it's greater than, what was it, 37? Shoot, I already forgot. No, 38 and 39. So it's greater than 38 degrees. Okay, it's greater than 38 degrees, and it's less than 39 degrees. So we could say it's about 39 degrees. We just have to give an estimate there. But let's see how we could use the inverse function of sine, cosine, or tangent to solve this missing angle. Inverse function means that we take this and we take this and we swap them. So I'm going to swap them. I'm going to say the inverse of sine function. This notation looks like to the negative first power. It really is the notation or the symbol to say that we're using the inverse function. So the inverse function of sine negative, sorry, I keep saying that. The inverse function of sine, and I'm going to take that of 15 over 24. You can see how I already flipped that. That's going to be equal to my angle measurement of x. So here is, this right here is the inverse function sine of 15 over 24. And that is how we'll use, that's how we'll solve for the angle. And I'll show you how to do that on my laptop. So what you can do is go to Google, go to Bing, go to Yahoo, whatever, and I'm going to write this in. And remember, we're in degrees, so I'm going to say degrees here. Okay, that's messy, but you get it. So I'm going to write inverse sine of, what was it, 17 over 24? Was that it? No, 15 over 24. 15 over 24, and look, I'm going to write degrees. Whenever I'm using my laptop calculator, I always specify degrees because sometimes they assume radians. And we're not measuring in radians, we're measuring in degrees. So I write the word degrees. There we go. It also is called arc sine, A-R-C, arc sine. So you could write arc sine up here instead, or you could write inverse sine. It's the same thing, and we get the value approximately 38.7 degrees, because remember, we're rounding to the nearest tenth. Here's the 10th place value. We have to decide if we round this to a 6 or to a 7. We look at the next one to the right, and if it's 5 or above, we round up. So we're going to round this to 38.7. So x is approximately 38.7 degrees. And that's my answer right there. And that's it. Okay, I'm going to rewrite that. Degrees. Sorry. Okay, degrees. So, pretty simple. Let's try number 2, and I will show you how to use it on a phone calculator. I can also show us how to use it on a scientific calculator, but let's go for number 2 right now. So here's my angle x, and we have this side and we have this side. We have to decide if they're hypotenuse, adjacent, or opposite. Well, I know this is going to be my hypotenuse side. This is the hypotenuse side. How do I know it's the hypotenuse side? Well, from my right angle, I go opposite of my right angle, and that's the hypotenuse. Easy. So from my angle x over here, this other side that's right next to my angle x, that's my adjacent side. So now we ask ourselves, which trig ratio concerns with hypotenuse and adjacent? Well, let's go look at SOH CAH TOA. Where do we see an A and an H? I see A and H right here with cosine. Cosine is adjacent over hypotenuse. So I'm going to take the cosine of my angle. Cosine of my angle x is equal to adjacent, because cosine is CAH, adjacent over my hypotenuse. And remember, we're going to use the inverse function. So we're going to take what's here and what's here, and we're going to flip them. We're going to flip positions. So the inverse cosine function of 8 over 11 is equal to my angle x in degrees. So in your calculator, you can do inverse cosine of 8 over 11 in degrees is equal to that value of our x angle. I'm going to show us how to use a phone calculator. So here I am. Remember, rotate your phone, be unlocked. What you have to do first is you have to put in the ratio first. So I'm going to put in 8. Nope, that's not 8. It's hard to do this backwards. 8 divided by 11, because that's the ratio we have, right? We have 8 over 11, because it's adjacent over hypotenuse, 8 over 11. And then I'm going to press, there's this button right here that says second. I'm going to press that second button, and a few of these functions, button functions change. Now you can see there's like sine -1, cosine -1, tangent -1, the inverse functions of sine, cosine, and tangent. We're going to press the inverse of cosine. Oh, what? Okay, sorry. 8 over 11. Oh, sorry. You have to press 8 over 11, and then you have to press enter. So you have to have that in the decimal. So that's 8 over 11 in the decimal, and now I'm going to press cosine -1. And there we go. There's our angle measurement. It's 43.34 whatever. And to double check that, let's go here. We're taking the inverse of cosine for 8 over 11. And there we go, 43.3. This time we're rounding just down to 0.3 because the next place value, the 4, is less than 5, so it's 43.3. Okay, so x is approximately 43.3 3 degrees. There's my answer, and that's it for number whatever, 2. All right, last little bit is some word problems. I hope you're still here with me. What time are we at? Okay, it's a little long, but that's okay. Here we go. Number 18, a spectator in the stands spots the team mascot on the field at an angle of depression of 46 degrees. If the spectator is sitting 35 feet above the ground, what is the horizontal distance between the mascot and the spectator? Quick side note, I'm going to go right, where do I want to go? No, I'll go up here actually. I'm going to go over what angle of depression and angle of elevation is. So here I am. If this is me, I look directly straight in front of me. This is called the line of sight, right? If you were to look right in front of you, you see whatever's in front of you. That's your line of sight. Now, what if there was like, I don't know, a bird up here? What you do is you would look up, right? Your eyes would elevate, they would go up, and they would look up to the bird. And here you can see the triangle develop. This is the right angle. And this angle here, this angle is the angle of elevation. Okay, now what if you were standing and trying to think of a better example. Okay, here's the other side. Let's say here's your boat and you're sailing, and here's the water, and here's the person, you know, looking, and they spot a turtle down here. I have no idea how to draw a turtle. Okay, there's the turtle, whatever, submarine, something's down there. Remember that this is your normal line of sight. Line of sight. And what happens is, to look at that turtle, your eyes have to go down, right? You have to look down to see that turtle. So again, we have a triangle developing. Here's the right angle. And now here, this is the angle of depression. Angle of depression. Okay. So that's how we decide angle of elevation and angle of depression. So spectator is in the stands, spots the team mascot on the field. Okay, so how am I going to draw this? Those are the bleachers, right? Here's my spectator standing. Oh my God, my foot's asleep. Okay, here's what would be the line of sight. Right? There's my line of sight. And here's the ground, because we're probably at like some kind of field. There's the ground. Here's the mascot. I don't know what the mascot is. There's the mascot. No, that's a really bad mascot. Okay, mascot, you get me. So what is happening is the person, the spectator in the stand, isn't going to look straight ahead of them to see the mascot. They're going to have to look down to look at the mascot. There's the line of sight, and that's how we connect our triangle. Here's the angle. This is the angle of depression. There's the angle of depression, okay? And that angle value right here is 46 degrees. So I'm going to write 46 degrees. Other thing to note that they told us was spectators sitting 35 feet above ground. So this height here is 35 degrees. Not 35 degrees, sorry, 35 feet. That means that this side over here is also 35 feet, right? Because it's the same height, because it's from the line of sight where the person was. So we have some information already. We have 35 over here in our triangle. We have an angle, and we're asked to see what is the horizontal distance between the spectator and the mascot. So they want us to find this distance here, or this distance up here. It's the same distance, so let's call this x. So here's our triangle that I'm going to work with. From my angle, 46 degrees, let's get this color. From my angle, 46 degrees, this side is the opposite side, okay? And this side over here is the adjacent side, because remember, this over here is the hypotenuse, it's the longest side, and it's the one opposite of our right angle. So we have over here adjacent. Which trig ratio deals with adjacent and deals with opposite? Okay, go back to SOH CAH TOA, and we see, where do we see O and H? Opposite and adjacent, right here for tangent. Let's go back down. So we're going to take the tangent of our angle. Tangent of our angle, tangent of angle 46 degrees is equal to, remember tangent is opposite first, 35 over adjacent x. And if you remember the shorthand trick, we flip these two things. So x is equal to 35 divided by tangent 46 degrees. Okay, I'm going to show us how to use a scientific calculator because I want to make sure we use all the different modes in this video. Here's my calculator. Remember, the thing that we're doing is 35 divided by tan 46. So I'm going to write 45 divided by, and here's sine, cosine, tangent, tangent 46. Oh, that's not what I meant. Press enter. And there's the value. I don't know if that's backwards for you. I get kind of confused, but I'll do it in the online calculator as well. 45 divided by tan 46. And don't forget the word degrees. There we go, 43.45. Let me show you what happens if you don't write degrees. Oh, well, it assumed degrees. Fine. Sometimes it doesn't assume degrees, so don't take your chances. In this case, oh gosh, sorry. In this case now we have x is approximately 43.5 feet. I include my measurement notation because we're measuring in feet in word problems. That's important. So there we go. That's the horizontal distance between the spectator and the mascot. All right. Last problem. Mephisto is sitting on the ground and flying a kite and lets 175 feet of string from the ground. Okay, quick note. Here's my ground. All right. Here's my ground. Oh, something's happening. How do I get rid of those? Go away. Okay. Here's my ground. Here's Mephisto sitting. And okay, holding a kite and lets 175 feet of string from the ground, and the kite itself is 97 feet. So let's see, here's my kite. There's the kite, and this is 97 feet. Oh wait, 97 feet above ground, 175 feet of string from the ground. So if this is the string of the kite, that's 175 feet. And what is the angle that the string makes with the ground? So this is where some people get confused, like what angle am I talking about? Angle that the string makes with the ground. Well, here's the string, here's the ground, that's the angle. So they're asking us to find this angle here. I'm going to call it theta. Theta is equal to my angle. That's what I call my angle in this case. Theta is just a Greek letter that we might use to label an angle. Okay, so we have to again ask ourselves, here's my angle. I have this side and this side. Which trig ratio do I use? Well, remember, this is my right angle over here. From my right angle to the opposite side is my hypotenuse. Here's my hypotenuse. And over here, from my angle to the opposite side, well, I got to the 97 side length, so there's my opposite side. Which trig ratio uses O and H, opposite and hypotenuse? That is sine. So we're going to go back down here. We're going to take the sine of my angle. So sine of my angle theta is equal to opposite first, opposite over my hypotenuse. Easy peasy. Last bit, and I'll show us how to do this on a trig calculator. No, I'll show us how to do this trigonometry, the inverse sine, right? We're taking, because to find this, we have to swap. We're going to swap these two things. So we're going to do inverse sine of 97 over 175 is equal to my angle theta. All right, let me show you how to use a calculator on this, and then we're done. Congratulations. Okay, so again, it's inverse sine of 97 over 175. To find the inverse sine on a graphing calculator or scientific calculator, press the second button up here. And then remember how there's the sine, the cosine, the tangent all along here? And then above there in my calculator, it's yellow. You can see the inverse sine button, the inverse cosine button, and the inverse tangent button. I'm taking inverse sine. And look, you can see the little -1 to show inverse. And inverse sine of 97 over 175. 97 divided by 175, inverse sine of that. There we go. That is the distance, right? Oh, that's the angle, sorry. That's the angle. And I'll show you again right here on the, whatever, search engine, 97 divided by 175. Remember, we want this in degrees. There we go, approximately 33.7. So right here, theta is about 33.7 degrees. And let me, oh, that kind of got messed up. Wait a minute. I don't know what just happened. That looks weird. Something weird happened. You notice that? Okay, well, that's all for the video. I'm just gonna, something weird happened to the OneNote, but that's it for the video. Thank you for watching. It's been an hour. I hope you enjoyed this time. I hope this is helpful. If you have any questions or concerns, please reach out to me on Teams message, email, talk to Thursday, whatever. I'll be out on Thursday and Friday, so I'll still be available via Teams if you really need me, but I am taking the days off, so I won't be there. Have a great day, and I hope you do really awesome on your test. All right, see you later.